Have you ever noticed how continents like Africa and South America look like they could fit together? That's not a coincidence. It's a clue to one of science's most powerful ideas, plate tectonics. This theory explains why we have mountains, earthquakes, and volcanoes, and why continents move over time. Imagine Earth's surface as a cracked eggshell, broken into massive slabs called tectonic plates. These plates drift, collide, and slide past each other at about the speed your fingernails grow. Over millions of years, this slow movement shapes our planet, building mountains, creating oceans, and rearranging continents. Plate tectonics is the master architect of our world, dictating where volcanoes erupt and where earthquakes strike. It's the grand unifying theory of geology, connecting Earth's past, present, and future. In this journey, we'll explore how these plates move, interact, and shape everything around us. Get ready to piece together the puzzle of our planet, a story written in stone, fire, and time. Let's get moving. Let's zoom in on Earth's surface. The lithosphere, our planet's rigid outer shell. The lithosphere is broken into about a dozen major tectonic plates, floating on the softer asthenosphere below. Picture giant rocky rafts drifting on a sea of hot, slow-moving taffy. Some plates, like the Pacific Plate, are mostly underwater. Others, like the Eurasian Plate, carry continents. The continents are passengers on these moving plates, so continental drift is really plate movement. Plate boundaries are where the action happens: earthquakes, volcanoes, and mountain building. These plates can be up to 200 kilometers thick, bending and breaking under immense stress. Studying plate tectonics is like being a detective, reading clues in mountains and ocean trenches. Every earthquake and volcano is a sign of this restless system. The Earth's surface is a dynamic mosaic, always changing. The idea that solid ground moves is mind-blowing, but the evidence is everywhere. Pop quiz. The rigid outer layer of the Earth broken into plates is called the answer lithosphere. What happens when these massive plates meet? That's where the magic and chaos happens. There are three main types of plate boundaries. First, divergent boundaries. Plates move apart, magma rises, and new crust forms, like a factory making new seafloor. Second, convergent boundaries. Plates collide. If an oceanic plate meets a continental plate, the denser oceanic plate sinks beneath in subduction. If two continents collide, they crumple up to form mountains. Third, transform boundaries. Plates grind past each other horizontally, building up stress until it's released as an earthquake. Divergent boundaries create new crust. Convergent boundaries destroy old crust or build mountains. Transform boundaries cause earthquakes. Almost all major geological events, volcanoes, earthquakes, mountain building, trace back to these boundaries. Understanding them is like having a decoder ring for Earth's surface. Fun fact: the Pacific Plate moves northwest at about 10 centimeters per year, the speed your hair grows. These three interactions shape our world. Let's see them in action. Let's see plate tectonics in action around the globe. First, the Mid-Atlantic Ridge, a divergent boundary where the North American and Eurasian plates pull apart, creating new seafloor and volcanic Iceland. Next, the Himalayas, a convergent boundary. The Indian Plate collides with the Eurasian Plate, crumpling up to form the world's tallest mountains, which are still growing. Finally, California's San Andreas Fault, a transform boundary where the Pacific Plate grinds past the North American Plate, causing frequent earthquakes. Los Angeles and San Francisco are on different plates. In millions of years, Louisiana could be a suburb of San Francisco. These real-world sites show plate tectonics is a living force, shaping land and shaking cities. From new ocean floors to towering peaks, the evidence is everywhere. By studying places like the Mid-Atlantic Ridge, Himalayas, and San Andreas Fault, scientists observe Earth's tectonic engine in action. Plate tectonics isn't just theory, it's happening right now. Pop quiz. What type of boundary created the Himalayas? Answer: a convergent boundary. So what's powerful enough to move continent-sized plates? The answer lies deep in the mantle. The mantle is hot, pressurized rock that flows slowly, like thick honey. Heat from Earth's formation and radioactive decay creates convection currents. Imagine boiling water. Hot material rises, cools, and sinks, creating a circular flow. Inside Earth, these convection currents act like a conveyor belt, dragging plates along. At divergent boundaries, rising hot mantle pushes plates apart. At convergent boundaries, sinking cooler mantle pulls plates together. This is called slab pull. Earth's internal heat is the engine of plate tectonics, recycling crust and reshaping the surface. It's a slow but unstoppable process, moving continents and building mountains. Without this heat engine, Earth would be a cold, static world. The slow dance of tectonic plates causes earthquakes, volcanoes, and mountains. Earthquakes happen when plates get stuck at boundaries, build up stress, then suddenly slip, releasing energy as seismic waves. The stronger the lock, the bigger the quake. Volcanoes form at divergent boundaries, like the Mid-Atlantic Ridge, and at subduction zones, where melting mantle creates magma that erupts to the surface. The ring of fire around the Pacific is packed with volcanoes and earthquakes. Mountains form when plates collide, like the Himalayas, or when volcanic eruptions build up layers of rock. Coastal ranges like the Andes combine volcanic activity and crustal uplift. These forces aren't random, they're the direct result of plate tectonics. The world's earthquakes, volcanoes, and mountain ranges map out the plate boundaries. Understanding plate movement helps us prepare for hazards and appreciate Earth's dynamic nature. The evidence is all around us, shaping the land we live on. Plate tectonics is the key to Earth's most dramatic events. Fun fact: the Ring of Fire has 75% of the world's volcanoes and 90% of its earthquakes. The idea of moving continents is surprisingly young. In 1912, Alfred Wegener proposed continental drift, noting the puzzle-like fit of continents and matching fossils across oceans. He imagined a supercontinent, Pangaea, but couldn't explain how continents moved, so most scientists rejected his idea. Decades later, sonar mapping of the ocean floor revealed the Mid-Atlantic Ridge and patterns in sea floor rocks. Scientists discovered new crust forming at ridges and magnetic stripes, showing Earth's field had flipped, evidence for seafloor spreading. This solved the mystery. Plates move as new seafloor pushes continents apart. By the late 1960s, plate tectonics became the unifying theory of geology. It was a scientific revolution, changing how we see our planet. Sometimes, a wild idea just needs the right evidence to change the world. So keep questioning and exploring. The next big discovery could be yours.